The search for extraterrestrial life has inspired countless science fiction stories and has even fueled missions by NASA. One of the most intriguing places in this search is Europa, a moon of Jupiter, which many believe could hold crucial information. Bill Nye, the well-known science guy, is among those who advocate for further exploration of Europa, believing that this celestial body might be key to unraveling the mysteries of life beyond Earth. NASA's Voyager 1 spacecraft, launched in 1977, made a groundbreaking discovery outside our solar system. This discovery has drawn the attention of some of the brightest minds today, including Bill Nye. What Voyager 1 found was ionized gas particles actively clashing and interacting just beyond the heliosphere, the bubble-like region created by the sun's solar wind. These readings provided significant insights into what conditions might be like beyond our solar system. Could these be indicators of extraterrestrial life? This question has captured the imagination of scientists and space enthusiasts alike. Bill Nye has long been a leading figure in the search for extraterrestrial life. His passion for the unknown is evident in his interviews and lectures, where he often emphasizes the importance of space exploration. The discovery made by Voyager 1 has further fueled this passion, offering new data that could potentially answer the age-old question: are we alone in the universe? To understand why this discovery is so significant, it's essential to revisit the early days of space exploration and the events leading up to the launch of Voyager 1. In the early 1970s, NASA had recently achieved a monumental feat by sending humans to the moon. This success ignited widespread excitement within the scientific community, and plans were soon underway to explore even farther into space. NASA's next goal was to study the outer planets of the solar system, but sending humans on such a mission was not yet feasible. The vast distances and the limitations of 1970s technology made it necessary to rely on robotic spacecraft for these ambitious explorations. At the time, the Cold War was in full swing, and the United States was in a fierce competition with the Soviet Union. This rivalry extended into space, where both nations were striving to demonstrate their technological superiority. The Soviets had made the first significant strides in space exploration, launching the first artificial satellite in 1957 and sending the first man Yuri Gagarin into space in 1961. However, the United States caught up with the Apollo 11 mission in 1969, landing astronauts Neil Armstrong and Buzz Aldrin on the moon. This victory was a turning point in the space race, but the U.S. knew it couldn't rest on its laurels. The competition with the Soviet Union continued to drive NASA's ambitions. To maintain their lead in space exploration, NASA needed to go beyond the moon, and the goal was now to explore the outer planets. The agency began designing spacecraft that could travel deep into space. One of NASA's first attempts was the Pioneer 10 spacecraft, launched in 1972, which became the first to fly by Jupiter and send back images. Pioneer 11 followed the next year, also heading toward the outer planets. However, NASA wanted a more advanced spacecraft that could capture detailed images and data from not only Jupiter but also Saturn, Uranus, and Neptune. This led to the development of the Voyager program. The plan was ambitious, to use a rare planetary alignment known as the Grand Tour to slingshot the spacecraft from one planet to another using gravitational forces. This alignment, occurring only once every 156 years, would allow NASA to study all the outer planets in a single mission, saving both time and money. To accomplish this, NASA built two Voyager spacecraft. Voyager 1 was intended to take a shorter route visiting Jupiter and Saturn, while Voyager 2 would take a longer path to reach Uranus and Neptune. On August 20, 1977, Voyager 2 was launched, followed by Voyager 1 on September 5 of the same year. These twin spacecraft would go on to make some of the most astonishing discoveries in the history of space exploration. Voyager 1 began capturing images of Jupiter on January 30, 1979. These pictures revealed details of the gas giant that had never been seen before, including its great red spot, a massive storm that has been raging for centuries. But Voyager 1's mission didn't end there. After completing its flyby of Jupiter, the spacecraft continued on to Saturn, where it sent back more groundbreaking data. The discoveries made by Voyager 1, particularly its detection of ionized gas particles outside the solar system, have had a profound impact on our understanding of the universe. As the Voyager missions continue to send data from the far reaches of space, the search for extraterrestrial life remains as urgent as ever. Bill Nye and other scientists believe that exploring places like Europa with its subsurface ocean could provide the next major breakthrough. What we learn from these missions could change our understanding of life in the universe forever. Every 96 seconds, Voyager 1 captured images and joined them together to create a colored stop-motion video. Using this technique, Voyager 1 was able to send back a movie showing 10 rotations of the largest gas giant. By February 10, Voyager 1 had moved into the planet's moon system, sending back footage of natural satellites revolving around the gas giant. By the following month, it discovered a thin ring of dust and ice surrounding the planet which was invisible from a far distance. This proved that Saturn was not the only planet surrounded by rings. The ring was just less than 30 meters in diameter, puzzling scientists with how much they didn't know about this planet. By March 5 of that year, Voyager 1 had its closest encounter with a large planet separated by a mere distance of 174,000 miles. During this event, the spacecraft encountered several of Jupiter's moons, including Io, Europa, Ganymede, and Callisto. The pictures it sent back provided great insight into these natural satellites, some of which had almost nothing in common with our moon. Europa was most notable for its smooth, icy surface covering a large ocean of water underneath. Many scientists believe that life could thrive beneath the ice, making the satellite a prime candidate for extraterrestrial life. After the spacecraft's time with Jupiter, a course correction was made to prevent it from becoming trapped in the planet's orbit. This was done in preparation for heading towards Saturn. By October of that year, another course correction was made to avoid a potential clash with Titan, one of Saturn's moons. The encounter with Saturn was just as remarkable as the previous one with Jupiter. The spacecraft discovered 5 new moons, a ring system with thousands of bands, transient clouds made up of particles called spokes, and a new ring that was not visible from a distance. By 1989, all planetary encounters were complete for both spacecraft, and they were officially declared part of the Voyager interstellar mission. The new goal was to go beyond the outer planets of the solar system and, if possible, even further. Voyager 1 entered interstellar space in August 2012, marking humanity's first journey into this uncharted region. Voyager 2 followed in November 2018. Both spacecraft continue their mission carrying a golden record with sounds and images meant to portray Earth's diversity and serve as a message to any potential extraterrestrial civilizations. Their findings continue to shape our understanding of the universe and pave the way for future interstellar missions. The legacy of the Voyager missions is not just in their discoveries, but in their role as pioneers for humanity's deeper exploration of space. The Voyager spacecraft, despite their age, continue to transmit valuable data as they journey further into interstellar space. Their instruments, though aging, still provide critical insights into cosmic radiation, magnetic fields, and the interaction between solar wind and interstellar matter. Scientists at NASA remain fascinated by the data they receive, as it helps refine our understanding of the universe beyond our solar system. One of the most profound aspects of the Voyager missions is the Golden Record, Na 12-inch gold-plated copper disc containing sounds, images, and messages from Earth. This record was designed to provide a snapshot of human civilization to any potential extraterrestrial intelligence that might encounter the spacecraft. It includes greetings in 55 languages, a variety of natural sounds from Earth, and music from different cultures. Carl Sagan, a key advocate of the project, described it as a bottle cast into the cosmic ocean in hopes that one day an advanced civilization might discover and interpret its contents. While the chances of the Golden Record ever being found by extraterrestrials are slim, its symbolic value is immeasurable. It represents humanity's curiosity, optimism, and desire to connect with the cosmos. Even if no one ever finds it, the record serves as a testament to the human spirit and our quest for knowledge. Meanwhile, the scientific legacy of the Voyager missions continues to influence new generations of researchers. The discoveries made by Voyager 1 and 2 have been instrumental in shaping future space missions. For example, NASA's Europa Clipper, set to launch in the 2030s, is inspired by Voyager's findings about Jupiter's moon Europa. The spacecraft's evidence of a subsurface ocean has led to increased interest in exploring Europa for signs of life. Additionally, the concept of interstellar travel has gained more serious consideration. Scientists are developing new propulsion technologies such as solar sails and nuclear fusion-powered spacecraft that could one day allow humans to send probes beyond our solar system at much higher speeds than the Voyagers. Projects like Breakthrough Starshot, which aims to send tiny laser-propelled spacecraft to the Alpha Centauri system, are directly inspired by the successes of Voyager. Despite their immense distance from Earth, Voyager 1 is over 14 billion miles away, and Voyager 2 is not far behind. Both spacecraft continue their silent journey into the unknown. They serve as a poignant reminder of humanity's insatiable curiosity and our willingness to push the boundaries of exploration. Even as their power supplies dwindle and their instruments eventually go silent, their contributions to science will endure for generations to come. The search for extraterrestrial life, fueled by discoveries from Voyager and other space missions, remains one of the most compelling scientific pursuits of our time. Scientists continue to look for biosignatures on exoplanets, analyze data from Mars rovers, and plan missions to ocean worlds like Enceladus and Europa. The universe is vast, and while we have yet to find definitive evidence of life beyond Earth, the discoveries made by Voyager suggest that the cosmos holds many more secrets waiting to be uncovered. As we look toward the future, the legacy of Voyager reminds us that exploration is an intrinsic part of what makes us human. Whether it's sending humans to Mars, deploying new space telescopes, or eventually launching interstellar probes capable of reaching distant star systems, the lessons learned from the Voyager missions will continue to guide us. In the grand scheme of the cosmos, our journey is only just beginning.